So we can get started. So this is Amy. Amy November December 2023. Okay, so that is the paper we are looking at, and the question that we are looking at that was under matrix is question 6. Question 6A. Okay, so it says compute the inverse. Compute the inverse of the matrix A is equal to, so we have 4, 1, 2, 8, 7, -3, 1, -3, 2. Okay, so that is part A, which we have there. Now, sometimes, when you're having online classes, there are times where maybe you lose the screen, maybe you lose the voice. Sure, be quick to inform me so that I can quickly do something about it. Yeah, so now, from here, the question says, hence solve a system of equation. So this was part A. Then part B says, hence solve a system of equation. So usually this is how questions come under matrices. And this question had 20 marks. This only part had 8 marks. Then the other part B, had 8 marks, where you are solving the system of equation. So here we are asked to find the inverse. So there are two things you need to understand about matrices. Okay, the first thing is how to solve questions, how to solve system of equations using Cramer's rule. The second one is how to solve system of equation using inverse method. There are only these two methods that you need to understand. Once you have understood these two, inverse methods and the Cramer's rule. Okay, once you understand these two, then there's no question that you're going to fail under matrices. And mainly, if you check most of the past papers, matrices carry about 20 marks. It's a full question on its own with about 20 marks. So, meaning that tells you that it's something that is worth knowing, because once you know matrices, you are assured of 20 free marks. So now let's see. First of all, in everything, whether you are using inverse or using Cramer's rule, you need to be able to solve for the determinant. You need to be able to solve for the determinant. So let's see how we can do the determinant of a 3x3 matrix. A determinant of a 3x3 matrix. Okay, so this is what the symbol for the determinant is equal to. So the determinant for a 3x3 matrix. So I want you to pay particular attention here. I want you to pay particular attention here. So when we are solving for the determinant, every matrix given has got position signs. Okay, so we have plus, minus, plus, minus, plus, minus, plus, minus, plus. Those are what we call as position signs. Okay, they may be called differently, but let's use position signs. So each position here, for every number here, has got a sign allocated to it. So this is plus, this is minus, this is plus, this is minus, this is plus, this is minus, plus, minus, plus. Okay, we have those position signs. Now, when we are solving for determinant, what we do is we pick either this row, or you can pick any of the columns. It depends on what you choose. So either pick one of these rows or pick one of these columns to be your focus. So if we say, for instance, we pick this row, we have picked that row. So after we have picked that row, what we are going to be doing is this. So we lock, since we are dealing with this row, so we can lock this column. After we have locked this column, we pick this number here, which is in the intersection, in the middle there, which is 4. So we pick the 4. When you look at the position sign is positive, so we leave it just like that. After I've picked the 4, then now we have a 2 by 2 matrix that has remained free here. So we have 7, we have -3, we have -3, and we have a 2. This is a 2 by 2 matrix that has remained after we have locked this and having our 4 here in the intersection. That's what you do first. Then you go to the second one. You go to the second one. So you go to the second one. Okay. So when you go to the second one, you are going to lock this middle column. And when you lock the middle column, you see that this number 8 here is our intersection, is in the intersection of the row that we are using against this one that we have just locked. So we find 8 here in the intersection. Then you look at the position sign is minus. So we put -8. Then when we lock this, we lock this. You look at the free numbers. These free numbers make what we call as a 2 by 2 matrix. So you have 1, 2, then -3, then 2 there. You close like that. Then finally, you go to the last part. Now, feel free to ask questions. Don't just be passing by. Feel free to ask questions where you feel you are not clear, because this is the final we are doing. This is the final revisions that we are doing. So if you don't understand here, it will be very tricky for you to understand again. Okay. So finally, we are going to lock this last column. And our intersection number is 1. And the position sign here is plus. I've just disturbed it there. Position number is plus. So we have plus 1. So it's a plus 1. Then now, after we have locked this and this, we see that this is the free, these 4 are the free numbers which form a 2 by 2 matrix. So I'm going to have 1, 7, 2, and -3, like that. So we know the determinant of a 3 by 3 matrix is something easier to do. So I'm going to say the determinant of A is equal to 4. Now we say major diagonal minus minor diagonal. So in the major diagonal, I have 7 times 2, which is 14, minus -3 times -3, we get +9. So 14 minus 9, then minus 8. Here 2 times 1, we get 2. Then minus 2 times -3, we get -6. Plus 1 times whatever we get here, it's everything there. So 1 times -3, we get -3, minus 2 times 7, we get 14. Okay, so that's what we get there. So this is going to be 14 minus 9, we get 5, minus 8, 2 minus 6, this will be 2 plus 6. So I have 8, then we have 2 plus 6, that will be another 8. Okay, then negative 3 minus 14, we get negative 17. Okay, we get negative 17. So negative 17 there, we come up here. So we come up here. So we're going to have 4 times 5, that would be 20. Negative 8 times 8, we get negative 64 minus 17. Okay, so this one, negative 64 minus 17, we get negative 81. Negative 81, when we add 20, we are going to get negative 61. So this is our determinant. Any question? Any question?
No, no question, but the proving part, what if you get a different number?
What if you get a different number where? On the determinant?
To prove, maybe you go, yeah.
Come again? I can't get you.
Okay, what if it's a different, let's say you try to prove and you use all 3 of the rows and columns, and then you get 2 which are similar and then 1 is wrong. It's okay to use the 2 which are similar, right?
So okay, is that a suggestion that we use all the 3 rows and see if we're going to get the same? Are you suggesting we go that way?
No. I was asking a question.
Yeah, the determinant should be the same.
Do that.
So the determinant should be the same.
Okay.
Even if you lock the column and then start changing this, changing that, you must get exactly the same answer. It should never be different. So it's not a matter of the 2 similar ones, the what. So you should just see whether there's a mistake you have made here and there and the like. Otherwise, whichever method you are going to use, the determinant must be exactly the same. So when you are sure of the method, there is no need of proving. But maybe for the sake of, in case of cases, you can pick another different way. That is, if you have enough time, and try it the other way around and solve it and then see what you get. Hope that's okay. Okay, so
Yeah, thank you.
we move forward, I guess so. Okay, so let's move forward. So now we are finding the inverse. So we have the determinant is the determinant of A is negative 61. So now we need to find the inverse. So how do we find the inverse? Okay, so now inverse, we are saying A inverse is simply equal to 1 over determinant of A times the adjoint of A. Okay, so 1 over determinant times the adjoint of A. Now, where we have a secret is how to find the adjoint there. How do we find the adjoint of A for a 3 by 3 matrix? That's where the secret is. Okay, so let me write my question again. So we have 4, 8, 1, 1, 7, negative 3, 2, negative 3, 2. Okay, so we have that. So now we need to find the adjoint because we have the determinant. So what we need is the adjoint. Should we find the adjoint, then we can simply we are okay. From there we are fine because we have 1 over determinant and we have the adjoint, would have found the inverse without a problem. So let's now go and do the inverse of n. I mean the adjoint of n. So to find the adjoint, now what you do is you are going to use the position signs plus, minus, plus, minus, plus, minus, plus, minus, plus. There are two ways here. It's either you transpose this or you work it out and when you are done, that's when you transpose. So whichever way would be easier. It's either you transpose it right there, then work it out. After you have worked it out, then you have found the answer. Or you can work it out now and then later on have it transposed. It's either way. So we can decide what to do. So, or maybe we can go direct and solve it here. So what we are doing is, this time around we are going to lock each and every number here. Okay? So we are going to lock each and every number here. So when we lock the 4 here, when we lock this 4 here, this number here, it means we have locked this row and this column. So what we are going to remain with, when I do this, we have locked this row and this column. So we are remaining with this. So we are going to form a very big matrix, which is the matrix of identities, of our determinants. So I have 7, -3, -3, 2. Okay, when we lock the 4 here, like this. Now this time around, we're going to block this and block that. So we're going to remain with this will be free and the other one will be free. So we're going to have, and when you see the position sign for this number here is negative. So I have negative, and then we have locked this, we have locked that, so we have these are free and those are free. So I have 1, 2, -3 and 2. Then finally we have this one, the position sign is plus, so we lock this and we lock that. So we're going to remain with this, which is 1, 2, 7, -3. So this is what we have for the first row. Now we go to the middle row. We go to the middle row. So the middle row, when we lock this and let me use another marker here. So when we block this and block the middle part here, we're going to see that we have 8, 1, -3 and 2 that are free. So we can use those. So I go, and there's a negative here, the position sign is negative. So I have negative, and then we block this, that we have 8, 1, 8, 1, -3, 2. This is what we're going to have there. Okay, so then from there we can lock this and lock that. So you see that when we block this middle row and the middle column, we're going to have 4, 1, 2, 2. So we're going to have, and the position sign for this middle number is plus. So we're going to have 4, 1, 2, 2. Okay. So again, when we block this column and the middle row, you see that this will be blocked and this middle column will be this middle row will be blocked. So I have 4, 8, 2, -3. So, and the position sign for this number is negative. So I'm going to have 4, 8, 2, -3. Okay, so we go to the final, last and final row. So when we block this and block that, we're going to have 8, 1, 7, -3. So, and the position sign here is positive. So we don't write anything, it's positive there. So here we're going to have, we said we block this, we block that. So I have 8, 1, 7, -3. So 8, 1, 7, -3. Okay, so this is forming a new matrix. Then we are blocking this and this. The position sign is negative, so this is gone and this is gone. So I have 4, 1, 1, -3. So this gives us 4, 1, 1, -3, like that. Then now finally, and the sign here is negative, sorry. Then finally here now we block this and we block that. the position sign is plus. So we block this, block that. So 4817. So that's what we have there. 4817. This is what we have. So this is a new matrix that we are going to form, which is the matrix of the determinants or the adjoints. So now from there we are saying this is going to give us, we are now solving the determinants of each and every single part here. So I'm saying 7 times 2, that is 14. So I'm going to say 14 minus negative 3 times negative 3, we get 9. So we have that. Then here we have the sign minus. 1 times 2 is 2 minus 2 times negative 3, we get negative 6. We come to the last part there, we have 1 times negative 3, we get negative 3 minus 2 times 7, that's 14. We have that. Then we come to the middle row. So it will be negative here, this negative. Then we're going to say 8 times 2, that is 16, minus negative 3 times 1, we get negative 3. See how I'm putting brackets? You should always be cautious. And then we go to the middle part, which is going to be 4 times 2, that is 8, minus 2 times 1, that is 2. We got finally to the last part there, we are saying 4 times negative 3, that would be negative 12, minus 8 times 2, that would be 16. We close, and we come to the final one here. So we are saying 8 times negative 3, that would be negative 24. So get negative 24 minus 7 times 1, that is 7. Then we have a minus here. So I'm saying 4 times negative 3, that is negative 12, minus 1 times 1, we get 1. Then finally now here we have 4 times 7, that is 28, minus 1 times 8, we get 8. Like that. I don't know if we are still together. If I've lost you, please let me know so that we can quickly work out things together. Don't forget the determinant. Don't forget determinant of A, we are saying is equal to negative 61. Okay, so let's lift this up. So I'm saying this is equal to okay, so 14 minus 9, that is 5. So I have 5. Then this has a minus outside. So 2 minus minus 6, so it to be 2 minus minus gives us plus. So 2 plus 6, that's 8. And there's a minus here. So you get minus 8. Then negative 3 minus 14, that would be negative 17. Okay. And then we come to the middle part. There's a negative outside. Then 16 minus minus 3. Minus minus will give us plus. So 16 plus 3, that would be 19. So there's a negative outside there. So we have 19. 8 minus 2, that will give us 6. Then there's a negative outside here. So I'm saying negative 12 minus 16. That would be negative 12 minus 16. So this would be negative 28. Okay, because we are going towards the negative 12 steps. Again, we are going towards the negative again 16. So this will, inside will be negative 28. We are adding towards the negative, or we are going towards negative 12 and 16. So it gives us negative 28 inside the brackets. But then there's a negative outside. So because of inside there's negative 28 times this negative, we're going to get positive 28. So you get 28 there. Please, if you are left behind, let me know quickly So minus 24 minus 20 minus 7. So minus 24 minus 7, we get minus 31. Okay. Then here we have a minus outside. And then we are saying minus 12 minus 1, it will be minus 13. Minus 13 times the minus, it will be plus 13. So here we have 13. 28 minus 8, that is 20. So we have 20 here. So this is what we have. Now, because we did not transpose when we started, we need to transpose this. How do we transpose? What do we do when transposing? This entire row becomes the column. This entire row becomes the middle column. This entire row becomes the third column. Or others will tell you to say, maybe you don't know which one is the simplest, which one is the easiest. Others will tell you to say, you simply maintain the diagonal numbers and then swap. This one comes here, negative 19 goes there. Negative 31 goes there, negative 17 comes here. 13 goes there, 28 comes there. That's what others will tell you. Okay? Yeah, but it doesn't matter what you do. What we're saying is this entire row becomes the first column. This second row becomes the second column. This third row becomes the third column. So this is going to give us, here we're going to have 5, negative 8, negative 17. Then here we're going to have negative 19, 6, 28. Then here we're going to have this coming that negative 31, negative 31, then we have 13, then 20. So this is our cofactor. So that's the matrix of cofactors. That's the matrix we have of cofactors. Any question on that? Any question on what we have done?
No.
Thank you.
No.
Yeah, thank you so much. That means everything is okay. So now from here we are saying, therefore A inverse is equal to, since we said A inverse is 1 over determinant times the adjoint, so we're going to have 1 negative 1 over 61. Okay, since our determinant is 61, then we multiply by 5, negative 8, negative 17, negative 19, 6, 28, negative 31, 13, 20. So that is our inverse. So this is our inverse here. So for doing this, you have 12 marks. Very simple and straightforward 12 marks. Yeah, I don't think there's anything difficult there. Then now from here, we are saying, now let's go to part B. If everything is okay here, then we can move to part B. Part B says, no. Let's go. Let's go. Okay, so part B says, part B says, hence Hence solve the system of equations. So we have 4x plus 8y plus z is equal to 2. And then we have x plus 7y minus 3z is equal to negative 14. So the last one is 2x minus 3y plus 2z is equal to 3. Okay. representing the relationship presenting the relationship among the angles of deflection of the ailerons. Okay, rudder and the elevator. For an aircraft in a coordinated turn. Okay, so this one had 8 marks. The one we are from solving had 12 marks. So this one had 8 marks. To sum it up to to make it 20 marks altogether, as in the whole question. Okay, so now all this that you see here, this is just language that is trying to make this mathematics fit AME, okay, aircraft maintenance engineering. So all this this language here is trying to balance up to say, okay, this paper, the ones that are doing it are AME students and they understand the ailerons, they understand the elevator and everything. So these equations are actually talking about this. Otherwise, this is mathematics, and the mathematical part is how to solve this system of equations at the end of the day. So now you have to rewrite these systems of equations. You pick the coefficients. You need to pick the coefficients of x, the coefficients of y, and the coefficients of z. Okay, you need to pick those. So the coefficient of x is 4, the coefficient of y is 8, the coefficient of z is 1. It's a number in front. So the coefficient of x is 1, the coefficient of y is 7, the coefficient of z is negative 3, the coefficient of x here is 2, the coefficient of y here is negative 3, the coefficient of z here is 2. So you have this. Then you are multiplying this by x, y, z. Then this will give you these numbers that are at the end here. So it will give you 2, negative 14, and 3. Okay, so this is how you transform this into a matrix. Since we are going to solve, we are going to work out matrices. Since we are doing matrices, so there's need of us to transform this into a matrix form. So what have we done? We picked the coefficients. The coefficients here, the numbers in front of the variables. So the coefficients here, and then multiplied them by x, y, z, then equated them to these numbers that are after the equal signs, which are those numbers there. That's basically what we have done. So now from there, since we are told hence, what it means, it simply means you are going to use the inverse method. You're going to use the inverse method to solve this system of equation. Because of the hence comes about because you have already done the inverse. So after you have done the inverse, now what do you need? You simply need to work out the problem using inverse method because you have already solved the inverse. Because when you are using inverse method, you are required to use to find the inverse when you are using inverse method. So you need to know that if we have the way it is here, the way this matrix has been presented. So this is our A, this is our X, and this is our B. Okay, so that is how it goes. So now we're going to say, if we write this as an equation, this is matrix A. This is the matrix of the variables x, y, and z. This is matrix B, which is the answer there. So if we were to write this as an equation, it's going to be AX is equal to B. If we are to find the value of this x, we are just trying to come up with a formula here. There's nothing that should confuse you. So if we want to come up with want to make x the subject of the formula, we can divide by a here, divide by a here. So that cancels. So x is equal to, now this is the same as saying 1 over a times b. Okay, this is the same as that because this b can multiply by that to give us b over a. So which is x is simply equal to 1 over a is same as a to the power negative 1 times b. So this now becomes our formula for the inverse method. So for us to find x, y, z, we are supposed to multiply the inverse times the matrix b there. Then we are done. That will be our answer for that. So now we know what our inverse is. We know what our inverse is, and we know what our b is. So we're going to say, using this formula, so we're going to say a inverse is negative 1 over 61, and then we have 5, negative 8, negative 17, negative 19, 6, 28, negative 31, 13, 20. Then times b, which is 2, negative 14, 3. This is what we have there. So when we work out this, we should be able to find the values of x, y, and z. Okay. So that's what we have there. Yeah. So now what we can do here is, let us maintain the negative 1 over 61, negative 1 over 61. Now let us multiply this by that. Okay. So when you're multiplying, you say row by column. So 5 times 2 plus 19 times 14 plus negative 31 times 3. That's how it goes. Again, you pick this times that, pick this times that. Okay. So here I'm going to say 5 times 2, that would be 10, plus negative 19 times 14. That's 266. So I have 266 Negative times positive, we are going to get minus. Then 31 times 3, we are going to get 93. Okay, so we are done multiplying this entire row by that column. Then we go to the second row, multiplying it by that column. So negative 8 times 2, we get negative 16. Okay, positive times negative, we get negative. 14 times 6, so 14 times 6, we get 84. Then 13 times 3, we get 13 times 3, we get 39. Okay, then from there we have negative 17 times 2. So 17 times 2, which is negative 34. Negative 34. Then we have 28 times negative 14. Of course, the answer will be negative. So saying 28 times 14, which will be negative 392. Then 20 times 3, we get 60. So this gives us negative 1 over 61. Then now we can add what is on top there. So we have 10 plus 266, okay, minus 93. We get 183. So here you have 183. Then we come to the middle one. We have 39 minus 84, then minus 16, which gives us negative 61. Okay, then the last one, when we go to the last one, we are going to get 60 minus 392, okay, minus 34. Okay, so you get negative 366. Okay, so now negative 1 over 61 times 183 is the same as saying when we have negative 1 over 61 times 183. This is 183 over 1. So it's the same as dividing this into that. So you can say 183 divided by 6. 183 divided by 6. We get 183 divided by 61, sorry. 183 divided by 61, we get since this is negative, so negative, this here 1, this here we have 3. So negative 1 times 3, the answer here gives us negative 3. So here we have, remember what we rubbed here was x is equal to A inverse times B, which is this one that we have here. So the x here simply represents x, y, and z, like that. So that's what the x represents. So whatever answers we are getting, so we simply have x, y, z. This is our x. Remember from what we had there, so this is equal to, now we say this times this, we get a 3. Then 61 and 61, they are going to cancel, so you get negative 1. Negative 1 times negative 1, we get 1. Then 61 into negative 366, so 366 divided by 61, we get 6. So negative, we get positive 6, like that. So here it's negative. So therefore, x is equal to negative 3, y is equal to 1, z is equal to 6. These are the values of x, y, z that we needed to provide. Any question? We are done with this question. The whole 20 marks is ours. So any question?
This formula is simple.
The inverse method is simple.
This one, the one we are just from solving just now, yes, it's easy.
Ah, okay. I hope so for Namakao as well. I hope you're also saying it's simple.
Straightforward.
Ah, okay. I was thinking we try Kramer's rule as well. What's your thought? So that you have a good choice in the exam.
Yes,
But
we
which
can
one
try.
do you recommend?
There are questions that are straightforward. Like for this question, it was indirectly telling you to say you need to use inverse. But there are questions that are just open-ended. You need to use anything that you know. So any method, either Kramer's or inverse. So those you may choose either to use Kramer's or to use inverse. So maybe we also look at Kramer's. Then once we are done with Kramer's, I think we are done with matrices.
Will you be sharing the video?
Yes, I'm actually going to cut it into two. So now that we are done with this one, I'll cut it and then I restart. I get another video because it will be too big, like if we take it for the whole 2 hours. So I'll share the video with you, don't worry.
I thank you.
Okay.